Another important performance metric in the network is delay, which is also often referred to as latency. In packet-switched networks, as packet passes through a series of links and routers from the source to the destination, it may experience several types of delay. We can summarize these delay types to transmission delay, nodal processing delay, queuing delay, and propagation delay. The total delay at each hop is a sum of these 4 types of delay. The time required to process a packet in a router causes the packet experience a delay in reaching the destination. This delay is called nodal processing delay. Examples of nodal processing include examining the header of the packet to determine the outgoing link, or error checking to find out if the packet has experienced bit level errors in the path from the source to this node. After the nodal processing is finished, the packet is placed in the queue for the outgoing link. At the queue, the packet experiences a queuing delay while it waits to be transmitted onto the link. This delay depends on traffic intensity and the number of packets earlier in the queue waiting to be sent out on the outgoing link. If the bandwidth capacity of this outgoing link is R, and the average length of the packets placed on the queue is L, and the average packet arrival rate is A, we can compute traffic intensity with LA over R. Traffic intensity can help us estimate the average queuing delay. If LA over R is almost 0, it means the queuing delay will be very small. By LA over R increasing towards 1, the link is being used near capacity. Therefore, with newer packets arriving, we will have longer and longer queuing. If LA over R is larger than 1, it means there is more work than it could be processed. This will result in long queuing delays and possible loss, as we will discuss later. Transmission delay is the time that is required to transmit all of the bits in a packet on the link. If the packet length is L, meaning that it has L bits, and the link rate is R bits per second, and the transmission delay will be L over R. This is because the time to transmit 1 bit will be 1 over R. And for L bits, the number will be L times 1 over R, which is L over R. Propagation delay is the time that is required to propagate a bit from beginning to the end of the link. Note that propagation depends on the medium of the link. For example, in fiber optics, since the bits transfer by light signals, propagation delay is calculated based on the speed of the light and the length of the link that it has to travel. Summing up the delay discussions, a packet experiences delay from 4 different sources: transmission, propagation, nodal processing, and queuing. Among these components, the nodal processing and queuing delays are harder to calculate as they depend on details of processing in a node and the number of earlier packets in the queue respectively, which might be hard to compute for specific cases. The total delay a packet experiences is the sum of these 4 components.